Hey everybody, welcome back to another fun and exciting geometry class. Today we are going to be talking about lesson 4.4, and lesson 4.4 is on page 197. Page 197, actually it starts on page 196. And on page 196 we're talking about the proportional division of lines. Specifically here we're talking about two different kinds of lines. One is going to be a triangle, and the other is just going to be like a set of lines with some transversals in it. So what are we talking about here? What are we doing? Well, let's look at it. Theorem 53 says, if a line is drawn through two sides of a triangle and is parallel to the third side, then it divides the triangle proportionally. All right, so let's break that down. What is that saying here? If a line is drawn through two sides of a triangle, okay, there's our line. It's drawn through two sides of this triangle, okay, side AC and side CB, and we have this line going through it, okay. Here's what it says. It says that it divides the triangle proportionally, okay. It does have to be parallel to what? Parallel to the third side. Okay, and in this case, I'm just going to tell you it is parallel to the third side. In other words, we could write AB is parallel to DE. That could be our given. All right, so there we go. There's our given information. We have a triangle. We have sides. Well, what this theorem tells us is that we have proportionality. What do I mean by that? Well, if you look here, I've written underneath of this, I've written some things here in yellow, okay? CD, so let's mark these sides. CD, okay, so this side right here, that's CD, over AD, okay? So these parts right here, CD and AD, those equal, proportionally equal CE, so that side right there, and EB. Now, they don't necessarily equal it. Now, the only way that that's going to equal it 100% is if it is an equilateral triangle or an isosceles triangle. So, in other words, if these two lengths are the same, this one is not equilateral and it's not isosceles. So, if those are the same, then your proportions will be exactly the same. Your numbers will be the same. But in this case, this side is a little bit longer. So let's just give it some values. I think that will help you if we give it some values. Let's call AD1, and let's call CD, we'll call that 4. Let's call CE 5. Okay? And here's what we're looking for. We're looking for EB. Well, what this theorem tells us is that if we know that this is parallel, and we do, that's part of the given, then we know that this basically is proportional to this side. This piece and this piece are proportional to this piece and this piece. So let's go ahead and just plug our numbers in and see what happens. All right, so let's write in our proportions here. So let's match these up. So CD is going to equal 4, and AD is going to equal 1, and that's going to equal the other side, which is CE, and that's going to equal 5, and BE, that is our X. So now let's go ahead and do the means times the extremes. And we're going to have 5 times 1 equals 4x. We'll go ahead and solve that. We get 5 equals 4x. We divide by 4 both sides, and we get x equals 5/4, or EB equals 5/4. Okay, that's the proportional size that EB would have based on the fact that corollary number 50 or theorem number 53 tells us that this line is, if this line is parallel to this line, then these pieces are going to be proportional, okay? So that's how all that works together. Just plug in the pieces, and that will give you what your missing side is. All right, look at corollary 53.1 there on page 197. It says, if a line is drawn through two sides of a triangle parallel to the third side, then either side is to one of the segments as the other side is to the corresponding segment. So what does that mean? Well, let's go ahead and let's go back to our original drawing here. Now, let's talk about what's the difference between the segment and what's the difference between the side. This right here is the segment. Okay, so that's segment CD. Okay, it's just the piece. This would be segment AD. The whole side is CA or AC. Okay, so what does this whole side equal? The whole side over here equals 5. What does this whole side over here equal? It equals 5 and, well, actually, this is probably better if we write this in 6 1/4. This is better if we write it like this, 1 1/4. We did have it 5/4, but in geometry, writing it in a mixed number is better than writing it in improper fractions. So we'll call that 1 1/4. So this entire side over here is going to be 6 1/4. Okay. Now, so those are the sides. Okay. The big numbers are the sides. That's the side and that's the side. That's AC and BC. Now, these other numbers are segments. So that segment is 4, this segment is 4, this segment is 1, and so on. Okay. Now, what this is saying, this corollary 53.1, is it says side AC. So, in other words, the whole side right here, so 5, we'll put 5 down here, is to DC. Okay, what's DC? That's this one right here. So, that's 4. So, 5 over 4 equals BC, this whole side. Okay, this whole side. So 6 1/4 is to EB. For EB, EC, sorry. This one right here to 5. There we go. All right, so there we go. And now what we would have is, this is interesting because we have a mean proportional right there. Didn't even plan that, but there you go. But these are proportional to each other. In other words, if you figured that out, if you reduce that, these two things would be the same. And next thing is corollary 53.2. 53.2. Corresponding segments cut off on two transversals by a series of parallels are proportional. Now, I want you to think about something. So here is our parallel lines. There's one, there's one, there's one, there's one. There's a series of parallel lines. And then here's our transversals. There's a transversal, there's another transversal. I want you to think about this. What happens if I just do this? What am I going to end up drawing right here? What shape am I drawing right there? And I know it's a little bit big, but I'm drawing a triangle, right? Okay, there's a triangle right there. And we have parallel lines cutting that triangle. Well, we're kind of combining multiple things here, but what we're doing is we're still using that corollary 53 because we have a triangle and we have parallel lines cutting it. So what they're saying is, in this case, this and this and this are proportional to this and this and this. And we've kind of already learned that before in another theorem and corollary, but now we're kind of taking it to the next level. We're saying if we have multiple parallel lines, it's still, every one of them is proportional, and it doesn't matter where the parallel line is. I mean, we could put another parallel line in right there, and these pieces in here, these little pieces, are still proportional to each other, okay? So if you take these two, it's going to be proportional to those two. And it's just the way it works with parallel lines and with transversals cutting them. All right, last thing for this lesson is Theorem 54. Theorem 54 is on page 198. And Theorem 54, all I wrote here is that it is the converse of Theorem 53. What does that mean? Well, it's the negative of it. It's the opposite of it. So what was Theorem 53? Well, let's go back and look at it. It's right here. If a line is drawn through two sides of a triangle and is parallel to the third side, then it divides the triangle proportionally. Well, in this theorem, Theorem 54, it's saying the same thing only backwards. In other words, it's saying if a line divides two sides of a triangle proportionally. So if this is proportional to this, and it is, then what we know from Theorem 54 is that this line must be parallel to this line. It has to be. So we can prove that lines are parallel. I wrote down here, this is a new way to prove parallel lines. Okay, so we've had like 2 or 3 different ways to prove parallel lines. Well, this is another way to prove parallel lines. You can prove parallel lines now with Theorem 53, and that says that if we have proportions here, if that's proportional, then the line is going to be parallel. What if this is not proportional? Well, then that would mean that this line is not, that it's not parallel. Okay, so if there's something wrong with the proportion, that means that the line isn't parallel. And it has to be perfectly parallel, and it has to be perfectly proportional. You can't have one that's off just a little bit. Even if it's off just a few decimal places or something, then the whole thing is off. That means it's not parallel. At some point in time, maybe, miles down the road, it will cross, but it's still not parallel. It's not perfectly parallel. So they have to be spot on, exactly the same. Well, that's all I have for you today. Hopefully you learned something. Just want to kind of refresh just a few of the things that I said there before I leave. Make sure that you remember, if these things are parallel to each other, then they're going to be proportional to each other. And if they're proportional to each other, they're going to be parallel to each other. That's the big takeaway from this lesson. So remember those as you go. All right, that's all I have for you. Hope you have a good one. Bye-bye.